Another class of organic compounds that we are going to study is ethers. They're also the derivatives of hydrocarbons. An ether can be represented by the general formula ROR. This R can be an alkyl group or an aryl group. What is an alkyl group? If you remove one of the hydrogen atoms from an alkane, the resulting species is called an alkyl radical. For example, if you remove one hydrogen atom from methane, you will get this. This is called methyl radical. If you remove a hydrogen atom from ethane, you will get this. An ethyl radical. This is benzene. It has got 6 hydrogen atoms. So we can remove one of the hydrogen atoms and we will get this. Let's say we have removed this hydrogen atom, so now we have a species with 5 hydrogen atoms. This hydrogen atom is gone. This radical is called an aryl radical. So in ethers, this R can be an alkyl radical or an aryl radical. For example, you can have CH3O, CH3. The name of this compound is dimethyl ether. You can have this is the ethyl group and this is the ethyl group, so you have diethyl ether. And you can have this. This is methyl phenyl ether. These are the derivatives of hydrocarbons. The next class of compounds that we have is known as the carbonyl compounds. Carbonyl compounds can be aldehydes or ketones. Now, what are carbonyl compounds? Carbonyl compounds are those organic compounds that have at least one carbonyl group. Organic compounds that have at least one carbonyl group. The carbonyl group is represented by this. For example, if we have this compound and we attach a carbonyl group, this will be called as aldehyde. If we have this alkyl group on both sides of the carbonyl group, that will be called as ketone. Let's talk about the structure of carbonyl compounds. So, the carbon and oxygen in the carbonyl group present in aldehydes and ketones consist of a sigma bond and a pi bond. Both carbon as well as oxygen of the carbonyl group are sp2 hybridized. Okay, the carbonyl compound has a carbon atom and an oxygen atom. So the carbon and oxygen atom of carbonyl compound are both sp2 hybridized. As a result, you get this structure. The three atoms attached to carbon lie in a plane with bond angles of approximately 120 degrees. The pi bond is formed by the overlap of p orbital of carbon with p orbital of oxygen. There are two unshared pair of electrons on oxygen atom of the carbonyl group. The carbon-oxygen bond distance is 1.23 angstrom, and the carbon-oxygen bond distance in alcohols and ethers is 1.43 angstrom. So let me draw the structure of carbonyl compounds. This is a carbon atom. It has got three sp2 hybridized orbitals which are lying like this at an angle of 120 degrees. This is an angle of 120 degrees. And this is oxygen. So it will form a bond with this here, a sigma bond, and there is one unhybridized orbital on carbon and one on oxygen. So they will have a parallel overlap resulting in a pi bond. So one of these bonds is a sigma bond and the other is the pi bond. And these two sp2 hybridized orbitals will form bond with alkyl group. For example, in this compound, one of the sp2 hybridized orbital is forming a bond with carbon. This one will form bond with the carbon atom of methyl group, and this one will form bond with the hydrogen atom. This is how carbonyl compounds are formed.